Today we're going to learn how to graph inequalities in standard form. The steps needed are 1. Rewrite equation in y equals mx plus b, which is slope-intercept form. Don't worry about the sign of the greater than or less than at this point, just imagine it's an equal to sign. 2. Graph the line as solid or dashed. 3. Test ordered pair in an original inequality. And 4. We're going to test shade our true region, also known as our feasible region. So here is example 1. We're going to do 2 examples today. So step 1, we need to go ahead and imagine it's just 2x minus 5y equals 10, and we're going to go ahead and solve this problem. In order to do so, we start by subtracting over our 2x. Now if you need to use your graphic organizer for this, that is fine. We get negative 5y equals negative 2x with a positive 10, so I put plus 10. Then I divide everything by negative 5. The negative 5's cancel out. I'm left with y equals negative divided by negative is a positive 2/5 x. Positive divided by negative is a negative. 10 divided by 5 is 2. So y equals 2/5 x minus 2. Now I go over to my graph paper. I'm going to go graph it, so I'm going to begin at negative 2. I'm going to rise 2, run 5. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5. I can do it in reverse, down 2, left 5. 1, 2, 3, 4, 5. And then using my straight edge, which is my ruler, I'm going to graph it. Now in order to graph this, we have to be careful about the sign right here. It says less than. Remember that when we do less than or greater than, it's going to be dashed. And if it's less than or equal to or greater than or equal to, it's going to be solid. So in this scenario, my line this time is going to be a dashed line. So using your ruler, you're going to draw yourself a line through the 3 points, adjusting as needed, or 4 points, or however many points you graphed. And it's going to be dashed. What that represents is that any point on this line does not work in this mathematical problem. So if somebody was to pick an ordered pair, it would not work in the problem. Now, when we do inequalities, there's not just one answer, there are multiple answers. So to figure out which side we shade to represent the multiple answers, we always pick an ordered pair. Now I know all you guys are hollering, the easiest ordered pair is 0, 0. And we can actually use it this time, so we're going to pick 0, 0. So the steps said that we take our ordered pair, which is 0, 0, and we plug it back into our original problem. So our original problem becomes 2 times 0, because that's my x, minus 5 times my x value, again, our y value, 0. The question is that less than 10? Well, 2 times 0 is 0. 5 times 0 is 0. 0 minus 0 is 0, which is less than 10. Our signs do match up, so this is true. So what we do now is we shade the true region. Since 0, 0 works in the problem, and it's above, we're going to shade above that dotted line. Now when we do so, the shading represents that if I were to pick any ordered pair, not just 0, 0, any ordered pair in this problem, it would work as long as it's in the shaded region. So anything below it won't work, so be careful with that. So there's how we graph that feasible region. Let's try one more of these. So the second one we're going to do is example 2. It says negative 3x minus 3y is less than or equal to negative 12. I don't have my y by itself. It is not isolated. So step 1, I need to go in and I need to rewrite it. So negative 3x minus 3y equals negative 12. This time I'm going to add the 3x over. Last problem I think we subtracted. So I'm going to add 3x over. I get negative 3y equals a positive 3x with a negative 12. I divide everything by negative 3. The negatives cancel, the 3's cancel, I get y equals 3 divided by negative 3 is negative 1x, or just negative x. 12 divided by 3 is 4, and a negative divided by a negative is a positive, so it's negative 1x plus 4. I go to my graph, I graph that, move, begin, so I'm going to begin at 4. 1, 2, 3, 4. I'm going to go slope of negative 1, so that's going to go downhill, so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, and now I'm going to graph it. Since my problem this time is less than or equal to, remember less than or equal to or greater than or equal to are solid lines, I get to use a solid line to graph this. So using your ruler or straight edge, you're going to graph that, making sure to put arrows on the ends of your graph. Now the difference is that less than or equal to or greater than or equal to, you can use points on the line. So if I pick any ordered pair on the line, it should work in the problem. I'm going to pick an ordered pair. The easiest ordered pair pick, of course, is 0, 0. So I'm going to pick 0, 0, and I'm going to take 0, 0, and I'm going to plug it back into the original inequality. So the problem is negative 3 times 0 minus 3 times 0. The question is it less than or equal to negative 12? Well, negative 3 times 0 is 0. Negative 3 times 0 is 0, so 0 minus 0 is 0. Bring down my negative 12. 0 is bigger than negative 12. Are my inequalities opening the same way? Well, they're not. So this is false. So 0, 0 does not work this time. So instead of shading the side where 0, 0 works, we're actually going to have to shade the other side of the math problem. So in this case, the other side of the equation. So 0, 0 doesn't work, so anything in the non-shaded region is not going to work in the problem, but anything up in the shaded yellow region is going to work in the math problem. And now we've done 2 examples of graphing inequalities.